Hello students, myself Professor Urvish Mehoda, Assistant Professor Electrical Department, Sri Swaminarayan Institute of Technology, Gandhinagar. I am a subject matter of testing and commissioning of electrical equipment, and GTU subject code of this subject is 2180901. I am welcoming all the students who are listening me through this platform, and this is the lecture number 2 of chapter number 1, that is safety management, that we are currently discussing. In last lecture we have discussed the safety management that should be provided from the premises and from the industries where the person is working with danger. Also the adverse effects of the high voltage, and it is say creepage and the clearance which is necessary between the electrodes. Also the we have discussed that the what is electric shock, and what facilities we should provide to protect a human being and equipment from the electric shock. So we have discussed what is earthing and the necessity of the earthing in the last lecture. So this is our second lecture, and in second lecture the topic number 6 is types of earthing. So let us discuss the types of earthing that is been done for the protection of the instrument and the system and to the human being. So let us discuss the types of earthing. So yes, the electrical equipment mainly consist of the two non-current carrying parts. So they are the neutral of the system or a frame. So yes, through the neutral there is no current is transferring, and the second portion of the instrument is its body, or we can say surface. So from the earthing of this two non-current carrying parts of the electrical system, the earthing can be classified in basically two types that we are providing for the protection of the system and the human being which is working with it. So first is a neutral earthing, and the second is equipment earthing. So let us discuss this both earthing in detail one by one. So first of all, what is actually a neutral earthing? So yes, it is neutral earthing is the neutral of the system which is directly connected to the earth by the help of galvanized iron wire. So GI wire basically we use for the earthing of an equipment. So yes, the neutral earthing, in the neutral earthing, the neutral of the system which is directly connected to the connected with the earth, and the earth wire material is GI, galvanized iron wire. And the neutral earthing is also called the system earthing. Why it is called system earthing? Because it is a type of earthing which is mostly provided to the system, and which has a star winding, or for the example, the neutral earthing is provided to the generator and transformer and motor. So basically we are having star and delta winding and wiring for such equipments. And whenever the star connection is in the equipment, so yes, we can easily take out the neutral from the star connection. So from the neutral wire, if we take take out a neutral wire, so that neutral wire is connected with the earth with GI wire. So it is the earthing of whole system. So that is why it is called a system. Means that's why it is called the such type of earthing is mostly provided for the system. That's why it is called the system earthing. And the instruments which are having such connections, or we can say star winding in its input. So it can be connected through a earthing wire with the help of it's neutral wire with the help of earthing, and we can protect the system through the neutral earthing. So it is all about the neutral earthing. Now let us discuss the equipment earthing. So what is actually the equipment earthing is this type of earthing is provided to the electrical equipment, and the generator and transformer itself an electrical equipment, but the non-current carrying part of the equipment, like their metallic frame is connected to the earth by the help of the conducting wire. So it is called the equipment earthing, because in this the neutral is connected with the GI, or we can say earth wire, and in this the body of the equipment is connected with the earth wire. So that's why it is called the equipment earthing. And if any fault occur in the apparatus which is in the premises, the short circuit current to pass the earth by the help of that wire which is provided on the body of equipment. So thus the protection can be provided, or we can cure the equipment from the damage, and a person who suppose who come into the contact of that faulty equipment, then we can save the one's life through both of the neutral earthing and equipment earthing. So these are the types of earthing. And what is the actually a difference between the equipment and neutral earthing? So let us discuss with this table given below. So this is an equipment earthing, and this is the neutral earthing. So yes, equipment earthing is a connection of non-current carrying metallic parts which is connected to the electrical equipment to the earth is called the equipment earthing. That we have already discussed, that the body or surface of any equipment is connected with a earth wire. It is called the equipment earthing. And in the neutral earthing, the connection of the neutral point which is connected to the three-phase transformer or generator or motor, etc., to the earth is called the neutral earthing. That we have already discussed in the previous definition. Now it is provided to the protection of the human being from the electric shock, and this is provided for the eliminating the arcing ground. Means whenever a fault occur in such large system, a large arc is been generated, and losses of charges will take place. So yes, we can protect this system with the help of neutral earthing and over voltage surges. And the third point in the equipment earthing is it has nothing to do with the stability, because a simple wire which is provided and which is not helping in the stability of the equipment, and through the neutral earthing we can provide the stability to the system. So stability of the system is increased just because of the neutral earthing, and we can eliminate the unwanted surges and arcing ground with the help of neutral earthing, so that the stability of the system will increase. Now equipment earthing is provided through the pipe earthing, plate earthing. These are the type that we use for the earthing. And neutral earthing is provided through the solid earthing, resistance earthing, and the reactance earthing. These are again a type of neutral earthing that we have discussed or we have already learned in the previous semesters for the neutral earthing and the equipment earthing. It does not provide in the equipment earthing, it does not provide any means of protection system against the earth fault. So whenever the earth fault occur, so it doesn't provide any protection, it just provide the earthing to the equipment, and it provides the suitable means of earth fault protection system. If we connect a earth fault relay with the system, and we can protect the whole system from the earth fault. And it is an equipment, it is called an equipment earthing, and this is it is a source of system earthing, so that's why it is called a system earthing. So this is these are the points which bifurcate the equipment earthing and the neutral earthing. So this is how we can differentiate the equipment earthing and neutral earthing. Such kind of question asked in your GTU exam, differentiate the equipment earthing and neutral earthing. So this is how we can discuss the equipment earthing and the neutral earthing. Now let us discuss the topic number 7, earth resistance. So earth resistance is necessary when we provide earthing to any equipment or any system. So yes, that we have already discussed, that earth resistance should be low than the human body, and the human body resistance is say around 1 kilo ohm. So we need to use a specific earthing wire with a specific earthing resistance, so that we can fulfill its function during the faulty condition. So let us discuss what is actually the earth resistance. So earth resistance is earth resistance which is connected on the frame. So the frame of the electrical equipment is connected to the earth electrode with the help of earth conductor. So that we have already discussed, that the frame of the any equipment which is connected with the GI wire, so which is called called the earthing. And when the fault occur, any type of fault occur, means the fault current goes to the ground through this earth electrode. So this is the necessary condition, means this is the necessary point that should be fulfilled with the help of earth electrode, because whenever such type of fault occur, it must be the charges must be transferred through the earth electrode, not from the human body. So this is the phenomena which is take place while the earthing fault, or we can say the discharging current is transferring through any equipment. So the resistance of the path through which the fault current reaches to ground is called the earthing resistance. Means the path which is which is taken from the charges to discharge from the charging body to the ground, is the path is called the earthing resistance. And the earth fault relay operates quickly and isolate the faulty equipment from the supply when the earthing resistance is less. So whenever we provide less earthing resistance, the earth fault relay will get operated just because of the heavy discharge through that earth wire, and earth fault relay will give command to the circuit breaker, and it will remove the equipment from the electrical supply, so that we can protect the electrical equipment. And if a person who comes under the contact of faulty electrical equipment from the high discharge just because of the fault. So earthing resistance is a resistance of path which is taken by the charges which are discharging through a medium. So yes, we should keep this resistance as low as possible, so that we can operate the earth fault relay, as well as we can protect the equipment and human being, which is whenever the such fault occur or such fault means happens. And if earthing resistance is more, then earth fault relay will take more time. Means yes, the low current will transfer through that resisting heavy resistance, and just because of the relay will not get sufficient current to get energized. So yes, it will take more time to get operate. And meanwhile, if the person comes in the contact of faulty equipment, will receive a shock, or the instrument means which is having that high discharging of the current will become faulty. So yes, if this is the main point that we should keep in mind. We should keep earth resistance as low as possible, so we can operate the earth fault relay in minimum time, and so that we can remove the faulty equipment from the electrical supply, and we can protect the instrument as well as the human being, which is comes under the contact of electric shock. So try to keep the earth resistance as less as possible, that we have already discussed, and therefore there will be not be the existence of potential between the frame and the machine and the ground. So there is no potential is created, so that's why no current is transferred through the means human body, which comes under the contact of that equipment. So yes, earth wire or we can say earthing electrode and surrounding soil decides the value of earth resistance. So if the soil is dry, then resistance of that soil is more, and if the soil where we have made the earthing, so it is yes, earth wire and earthing electrode and the surrounding soil which decides the value of earthing resistance. So if the soil is as I have already discussed that if soil is moist or having more water, then the resistance of the soil is less. So yes, in this earth wire and earth electrode are the conductors, so which offers the less resistance, but the surrounding soil will be offer more resistance, because as we move away from the earth electrode, the resistance of the soil will be increased, or we can say potential will decrease. So only the soil surrounding earth electrode is kept moist, so that we can reduce the earth resistance, and we can discharge that heavy charges whenever the fault occurs, and we will have a sudden operation of the earth fault relay, and we can remove our equipment from the electrical supply. So let us discuss that how this soil resistance will be the most important factor. So in this diagram you can see that change in the earth resistance. So change in the earth resistance with distance. So over here you can see that this is this x-axis is denoting the distance, and this is the y-axis, which is denoting the voltage drop between the solid electrode and the resistance of the general mass of the earth. So over here you can see that if the distance in the change in the earth resistance is less, or we can say less, so at that time voltage drop between the solid and earth electrode will be more. And if the distance from the earth electrode will increase, though gradually the voltage drop between the solid electrode will decrease. So this is how the earth resistance will affect the or we can say this is the factor that we should keep in mind while we are providing the earthing to the any electrode. And the fold current spreads into the ground through electrode. That is obvious that the soil is having a ground potential, or we can say zero potential. So the heavy current which is transferring through any equipment which discharge through a ground, so the earth resistance goes on decreasing as we go away from the electrode. So that is obviously shown in this diagram. It is showing that if we go away from the electrode, the earth resistance will the earth resistance goes on decreasing when we go away from the electrode. That is necessary thing. And the voltage drop between the point on ground, or we can say the point where we placed our electrode near the earth electrode, the point on ground away from the electrode decreases as the distance from the electrode increases. That is shown in this graph that we have already discussed. So the value of earth resistance is inversely proportional to the square of the distance. So if distance is more, the earth resistance will be less. Earth resistance is less, it means distance is more, and if earth resistance is more, the distance is less. So both are inversely proportional. So that we have to keep in mind while we are providing the earthing. And the earth resistance also decreases as the distance from the electrode increases. And at point B over here you can see that the resistance becomes 0, and the area of the electrode to be point is called the area of electrode resistance. So this is the point. From this point to this point is called the area of electrode resistance. So this is the place that we should keep low resistance while we are providing earthing rod or earthing pit or earthing electrode. We should cap the minimum resistance. We should keep minimum resistance of this portion, so that we can discharge that heavy current, or we can say potential, whenever the earth fold occur. And thus the earth resistance is not only a resistance between the electrode and ground, but the resistance between the electrode and the point at which the resistance becomes 0. So yes, the point where the resistance becomes 0 and the point where the electrode is placed, it is the most important place where we should keep in mind, where we should keep the earth resistance as low as possible to fulfill the work of earthing rod. So let us discuss that the topic number 8, factors which are affecting the earth resistance, that we should keep in mind while we are providing the earthing to any equipment or any system. So in order to decide the permissible earthing resistance, one point should be come into the mind, that is earthing resistance, and that we should keep as minimum as possible for the better output. And it should be low as possible, so that the value of earth fold current can be obtained, and with the help of which the earth fold relay can operate, that we already discussed. So this is the main point that we should keep in mind while we are providing the earthing, and this is the main factor, that is earth resistance. So we should keep it as minimum as possible where we have placed our earth rod. The value of earth resistance does not remain constant, because day by day because of the surrounding atmosphere and the quality of the air, the earth resistance will get deteriorate. So uh, we should keep the earth resistance as minimum as possible by adding some impurities and a moisture at the place where we have placed our electrode. So but it depending upon the following factors, the factors which are types of soil. The types of soils are sandy, rocky and sticky soil. So these are the type of soil where we should give more concentration. If we use having a sandy soil, then we need to pour more water and impurities to keep our area with minimum resistance. Again, a rocky and the sticky soil. So these are the type of soil where we have to pay our concentration for to maintain the earth resistance of the area. And second factor, that is amount of moisture in the soil. So this is the most we can say important point according to the type of soil that we have already discussed in the first point. And the second is temperature of the soil. So this is again a main factor. If the temperature of the soil is more, so the soil is not that soil is not moist. And if the temperature of the soil is less, then the moisture we can, if we pour a moisture, or if we add a motor if we add a moisture inside the soil, will remain for long time. So it will remain moist for long time if the temperature of the soil is less. And if the temperature of the soil is more, then we have to pay more attention in the moisture of that portion where we have provided our earth electrode. And size of earthing electrode and distance between the electrode. So this is the again of major factor that affect the earth resistance. If there are more than one electrode, then we should keep in mind the size of the earthing electrode and the distance between the electrode. So according to our requirement, we can place n number of earth electrodes, and we can keep a specific distance between electrode to maintain a proper earth resistance of the soil. And depth of the electrode under the ground. So this is the again a major factor. If we will not get a proper depth, then we cannot maintain the earth resistance proper. So we have to pay more attention to maintain the earth resistance of that area. And metal of earth wire and electrode. Yes, the type of metal that we are using for the earthing, that is again a major factor. So generally we use a GI or GI wire, and the plate we use generally is copper plate for the earthing. And when the capacity of the equipment is more, we should keep earth resistance as low as possible. So this is the major factor. If the capacity of the equipment is more, so we have to reduce earth resistance as minimum as possible. And for that we have to pour more impurities and more water at the place where we have placed our electrode. And when the capacity of the equipment is more, the value of the short circuit current becomes large. So the resistance we should keep as minimum as possible, so that the heavy charges can transfer through that electric rod, that earth electrode. And only reactance remains the circuit. So resistance will become zero, or we can say negligible, and reactance of that earth electrode will remain in the circuit. So these are the points, the factors that which affect the earth resistance, that we should keep in mind while we are placing the earthing. And this is is the type of equipment. Means if the equipment capacity is more than the value of the short circuit current, that we should keep in mind. So the capacity of the equipment is more than short circuit current will be large, and if the capacity of the instrument is less, then short circuit current will be less. So according to the level of current, short circuit current, we should provide a proper earthing scheme to the particular system, so that we can cure our system and the person who is working with the system from the injury or any danger. So let us discuss again the continue, that is factors which are affecting the earth resistance. But in that, this is the major factor that we have discussed, that if we keep a specific resistance, or we can say earth resistance as low as possible, then it will get eliminated and only the reactance will remain. So these are the three generators which are connected through this ground. So through this case study, we are discussing how the reactance which affect the earthing resistance. So let us find out through one illustration which is given here. So here we have considered the two alternators which are working in parallel. We have shown over here three alternators, and which are connected to a bus bar. So this are the bus bar. This is the bus bar through which this three instruments which are connected. And when a fault occurs on the bus bar, the equivalent reactance will become. So these are in parallel. So 1 upon x is equal to 1 upon x1 plus 1 upon x2. So all having the same reactance. So that is 1 upon 20 plus 1 upon 20. So x x become 10 ohm for a particular generator. So over here you can see that it is the reactance of the generator is 10 ohm. And if we when the more alternators are connected, so these are the three alternators in parallel, so the equivalent reactance will be, so 1 upon x is equal to 1 upon 20 plus 1 upon 20 plus 1 upon 20. So the reactance compared to the two alternators, reactance of the system comparing to the two alternators, over here you can see that for the two alternators the reactance is 10 ohm, and for three alternators the reactance is reduced from 10 ohm to 6.66 ohms. So from this we can see that equivalent resistance decreases, so the value of the short circuit current increases when the network becomes large. So yes, equivalent resistance decreases. So if the system is large, then the short circuit current is high, that we have discussed in the previous slide. And this is the we can say proof of the short circuit current increases as the system is large. So we have that we have discussed through this illustration. In this illustration we have discussed that if we are having two alternators, the reactance is 10 ohm, and if we increase the n number of alternators or generators, then the reactance will decrease according to the increasing of the number of alternators. So as the system become large, the short circuit current also increases, and when the network become less, or we can say less number of equipment, the short circuit current will be less. So this is how we can explain the increasing of the reactance with increasing of the system. So hence the earth resistance should be low as possible, so for the large system. So this is how we can discuss the factors which are affecting the earth resistance. So let us discuss these factors with the table. So the table which is shown below, the maximum permissible earthing resistance that we should keep for the small and large system for different installation as per Indian electricity rules. So this rules, according to these rules, we should keep our the resistance of particular area. So over here you can see that large power station, the maximum permissible resistance is 0.50 ohm. For big power station or substation, so it is 1 ohm. For small substation it is 2 ohm, and the domestic installation it is 8 ohms, and the earthing plate to any part of the circuit is 1 ohm. So this is the maximum permissible reactance as per Indian electricity rule that we should keep in mind while we are providing the earthing. And this is the permissible resistance that we should keep to protect our system from the fault. So this is how we can discuss the factors which are affect the soil resistance, and the points that we should keep in mind while providing the earthing. So after this lecture, if you have any query and doubt, you are feel free you can feel free to call me anytime to discuss queries related to this topic. And we can discuss means your doubts and queries in our doubt solving sessions also. So thank you very much, student. Thank you all. This is all about the lecture number 2. Jai Swaminarayan.